This is going to be part 4 to reaction kinetics. And today we're going to be specifically looking at reaction mechanisms. The big idea in this video is going to be that reactions don't take place in just one step. They can take multiple steps, such as 2 or 3 or even more. In order to understand this concept, we can use this diagram. It is the analogy of building a house. As we can see, it is not only done in one step. There are 3 steps that are needed to occur in order for the completed product of a nice built house. These 3 steps, we call them each a elementary process. So, let's take a look at it. In the first step, we can see the base of a house combining with the roof of a house in order to make a base and a roof of a house together. Next, in the second step, that same base and roof of a house is combined with the door to make a base, a roof, and a door of a house. So this base and roof that is being produced in one step and used up in a subsequent step is what we call a reaction intermediate. The definition of a reaction intermediate is species that are produced and then used up in a subsequent step of the reaction. So as you can see, it's produced in step 1 and then used up in step 2. Pretty simple. What we also must understand is that these steps have different rates. So in the past videos, we learned about rates, how we can make the rates faster, how we can make the rates slower, and what affects them. So what if I told you that step 1 had a slow reaction rate, step 2 had a fast reaction rate, and step 3 as well had a fast reaction rate? Since all these elementary processes come together for technically one reaction, we must determine which elementary process's rate will determine the rate of the entire reaction. Well, the answer to that is that the rate of the overall reaction depends on the slowest step. Now, looking back at our reaction, we can see that step 1 has the slowest reaction rate, whereas the other ones are fast. So therefore, step 1 determines the rate of the reaction. Step 1 is what we call the rate determining step, or the RDS. So now, moving away from analogies, let's take a look at actual reactions. So we can see that this reaction has 2 elementary processes. And what we're looking for is the overall reaction. But how do we find this? We can't just simply add these together. What we learned before is how to determine what a reaction intermediate is. Remember that it is a species that is produced and then used up in a subsequent step of the reaction. So as you can see, in this 2-step reaction, H3O2+ is produced in step 1 and then used up in step 2. So we can recognize this as a reaction intermediate. From here, we can go ahead and cross it out. We do not include reaction intermediates into the overall reaction because they are produced and then used up, so there is nothing left of them. It looks like H3O2+ was the only reaction intermediate, so therefore we can go ahead and write out the overall reaction. All we have to do for that is take the reactants, move them all down into the reactant side, and then take the products and move them down into the product side, like so. Now, this is our overall reaction, but we're missing one thing. What else did we also learn? We learned about the rate determining step. As you can see, step 2 is going to be considered the rate determining step because it has the slowest reaction rate. So therefore, this overall reaction rate cannot be fast. It is determined by the rate determining step, which we determined is step 2, which is slow. So therefore, the overall reaction will as well be slow.